So hopefully, since I made these up, they actually, whenever I did the multiplication, I didn't make any mistakes because I did it kind of quickly last hour. Okay, start with, this isn't all part of the rational zero test. That was just the header, but first off, whenever we do this, what we're going to do is we're going to do rational root test, which is P over Q. P over Q is a form for our zeros that what we do is we create a list of possible zeros for our polynomial. From this list, we take this list and we test them using synthetic division. If we get a remainder of 0, a remainder of 0 means that it is a 0. So anytime you take a number and divide a polynomial by it and you get 0 as a remainder, it means it's a 0 or a factor. Okay, so the way we get the P's and the Q's. P is the factors of your constant term. Q is the factors of your leading coefficient. And the problem is, depending on how large your numbers are, you could have a huge list of possibilities. But if your power is larger than 2, this is about your only option. Because we can factor things with the power of 2. We have quadratic formula will work for everything. Completing the square will work for everything. Stupid phone. Hello? Uh-huh. Good. Yes. Okay. Basically, they were sent out to go, and we were having a project. I sent 2 students to go and take measurements for the project, and Gabby decided that she was just going to go also. She was part of the group, but I was only seeing 2 people from each group. All the groups have 3 to 4 people. But I didn't want that many people down in the gym foyer unsupervised. So out of each group, I was only sending 2 people. And the group I sent, I don't remember which 2 they were. I think it was Fatima and Alize. No. I mean, the score comes from the final project, not from going and taking measurements. We took measurements as a class last week. And then they were just, they missed a couple measurements. So I sent 2 people down to get measurements that they missed. And Gabby just decided that she was going to go too, even though she was told no. And she argued and walked out of the classroom anyway. Okay, no problem. Bye. Okay, sorry. Write-ups always come back to haunt you. Okay, anyway, so this is a way to do anything larger. Now, the problem is this doesn't always work either. But if this doesn't work, then the way we do it is, what is it called? I think it's Gauss's. Is it Gauss or Euler? I can't ever remember between the two names. I don't know. I had to do it for my master's degree, but it's been a while. I had to write up a whole paper about it. But basically, I want to say it's Gauss. Basically, what you do is you have to guess at where the zero is, because you know that on this side, if you pick a number and you plug it into your formula, you get a positive. On this side, wherever you plug it into a number, you get a negative. So what you do is then you pick a number halfway in the middle. Okay, well, I pick a number halfway in the middle. I plug it in, I get a positive, so I throw this entire part away. Well, then I pick a number halfway in the middle. Well, that one was negative, so I throw this piece away. So I pick another number halfway in the middle. Well, that one's negative, so I throw this piece away. And you keep going back and forth until you get a number that is far enough decimal places that you're happy with it. And you just keep going back and forth. It's something you plug into a computer. You program your computer to do it. And that's how your graphing calculators are programmed to do it. This is something that this is not what this does. This is what you do if this fails. This is what's left over. And there is whole classes on ways of optimizing this process. There are different processes, different methods for optimizing this. There are classes in college on how to do that. No, you don't need to know this. I just want you to know that this is why this is our last step, because there is no step beyond this besides doing this sort of thing.
How many decimal places would they go to?
Depends on what your problem is requiring. And again, you would want to pick more than 3, because even whenever you get to 3 decimal places, you may be going back and forth a few times before you get to your 4th decimal place. So it depends on what your problem calls for. And a lot of that depends on your physical constraints, because at that point you're talking about real world situations. Okay. So, let's actually do this. So, for this problem, P would be factors of 6. The negative doesn't matter because we consider both positive and negatives. So, I'd have positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 6. So, I choose all factors of 6. Q is all the factors of my leading coefficient, which luckily for me is 1. So P yes, constant term is your last one. So this is where your P comes from. Q comes from your first number, which in this case is 1. Yep. No, you're fine. So then the numbers we want to divide by is we take each of these numbers and divide it by each of these numbers. Yeah. Numbers that I can divide 6 by. So in this case, we're lucky because since Q is only 1, I can only divide these numbers by 1. So my list is a bunch of whole numbers. Okay, at this point, it's guessing. So you just start picking out numbers and guessing at which ones might work. And then using synthetic division to test them out.
since we have x cubed, we have a possibility of 3 that would work. I mean, possibly none would work. Well, actually, we have to have 1 that works on this because irrational numbers have to work in conjugate pairs. So we have to have at least 1 number that would work on this one. 1 works? Okay, so we put 1 in. And we get 0. Okay, now, you could keep testing numbers, but once we get down to 3 numbers here, that means that this is this, correct? We have lots of ways of solving something with an x squared. So why go through all this hassle of guessing? Well, this is actually factorable, right? So x would equal -2 and -3. Okay, your problems are going to ask for 2 things. Your problems are going to ask for zeros. So my zeros are 1, -2, and -3. And it's also going to ask for f of x in factored form. Now, if you get to something like this, and whenever, let's say it's not factorable, and you have to use quadratic formula, and you get something terribly, terribly ugly for zeros. So let's say instead of getting something like this, so this is kind of offshoot, this isn't part of the problem. Let's say I went and I had something, and I don't care what it is, but let's say my zeros ended up looking like this. Here, let me do that. Sorry. Let's say that I got that. So my zeros are plus or minus I. Whenever I go to write out my factors, so my zeros, so who knows how many zeros I have? I don't care how many zeros I have, but my zeros would include I and negative I. Whenever I go to write out my factors, you know, I have some factors here. I do not write these as factors. Those are not factors. Because I cannot factor and get this as a factor, right? The last factor I could get was that. Factors are something you can get by factoring. So the last factor I had was this. So factors should never have square roots or i's in them. Your book will disagree with that. I don't care what your book says. Factors should never have i's or square roots in it. So this here, if it's not factorable, this is your last factor. If it is factorable, great. Then here's your factor. But if you have to use quadratic formula to get something with square roots in it, then this was your last factor. All right, are we okay? Can I move on to do another one? Okay. Okay, I made this one so it didn't have a whole lot of choices. So P would be 1 or 2, right? Plus or minus 1, plus or minus 2. Q would be plus or minus 1. So again, since Q is just 1, that means those are our choices. Okay, any guesses? -1?
Yeah, negative 1.
Okay, so since I still have 4 numbers, I have to guess again. I can't stop guessing until I get down to 3 numbers. Now, you cannot cross out a number until it fails. If you test a number and it fails, you can throw it away. Once it fails, it will never work again. But if a number does not fail, it can actually work multiple times because the number can have multiplicity, right? So, -1 actually might work again. So we have to test it again. Oh, and look, it worked again. So that was the point on this one, is I wanted to show you that if a 0 doesn't work, we can throw it away. Because if it doesn't work once, it will never work.
So you can use a number multiple times.
But yes, you can use a number multiple times. Now that we're down to this, we can try factoring it, or we can use quadratic formula. This is actually factorable. So -1 would have actually worked yet another time.
Could it be possible that let's say if we were to continue down factoring here, could this number be like -2 and this number be -1, or it has to be consecutive?
No. You can use anything. Doesn't matter the order.
So this can be like this can be, let's say it was -2. This can be -1 then,
It doesn't matter what order you choose them in.
as long as it works once. It can. Okay.
So technically my zeros are -1 and 2. My factors are x plus 1 cubed because it worked 3 times, and x minus 2.
Wait, there's nothing that is factorable in has 3.
Once it has 3, you can factor or use quadratic formula.
Oh, so the -1 came from the game 3 times.
Yep. Yeah.
If you do it another time, you have to use the same number.
No, you can use any number you want to. If you don't think that number will work again, you don't have to try it. You can do it however you want. I knew it was going to work, that's why I did it, just to save time. I normally, if we weren't time crunched, I would sit here and make you guys guess over and over and over again. I want to do one more. This was this was the one I wanted to do.
God.
But this was my backup in case we hit the 10-minute bell. Because I wanted to do one where we would have fractions. Okay, so with 16, all the numbers that divide 16. So 1, 2, 3 doesn't divide 16, but 4 does. See, 5 doesn't, 6 doesn't, 7 doesn't, 8 does. Okay, so now I've hit the other side of that, so 16 is the other number. Okay, Q, all the numbers that divide 4 would be 1, 2, and 4. So now I'm going to have some fractions. So P over Q. So I take all these numbers and divide them by 1. Okay, then I take all those numbers and I divide them by 2. Now, I don't have to list them all out because what's 2 divided by 2? 1, so that one's already there. What's 4 divided by 2? 2, so that one's already there. 8 divided by 2 is already there. 16 divided by 2 is already there. Awesome. All right, 1 divided by 4. Okay, 4 divided by, or 2 divided by 4 is already there. 4 divided by 4 is already there. 8 divided by 4 is already there. 16 divided by 4 is already there. So it wasn't as bad as it looked. You know, it could be worse. I could have been dividing by a number like 9. That would have been a lot worse.
I want you to divide by 4.
I did divide by 4. But wherever I'm dividing by 4, the only number that shows up is 1/4 because all the rest of them are already listed up here. Because 2 divided by 4 is 1/2. 4 divided by 4 is 1. 8 divided by 4 is 2. 16 divided by 4 is 4. So they're already listed. All right, now we have to test them. So we choose. Let's choose one that doesn't work just to make sure you guys are okay with what happens whenever it does not work. -1. Okay, so if I try -1. I say a lot of these aren't going to work. Let's see, that's 28. So -28. 40, that's, I need a calculator. My brain's not working. What? 35? That is a really big number. Not really big, but bigger than what I want to do. 43. So, I didn't get 0, doesn't work. Okay, so a number that will work is 1/2. So 1/2 worked. Another number that would work. Where's my list? -4. not negative, just 18. Let's see, negative 72, right? Okay, that is small enough that we can divide. Now, let me show you one more thing. Let's say that we weren't low enough that we could divide. Notice that my last number is now 8. Once my last number is 8, I can reevaluate the numbers up here. So I could cross out numbers that are not divisible by 8. That's not a huge list, but you know, if you're like that 432, that's why I wanted to show you. If we divide by something with the 432, we would have been able to cross out a lot of things once our number decreased from 432. So just keep that in mind. Once your n number decreases, you can change your list up here. Okay, but we don't need to do that because 4x squared plus 18x plus 8 equals 0. Well, everything is divisible by 2, so 2x squared plus 9x plus 4 equals 0. That's factorable, but I don't want to factor. Let's see, 4 times 4 times 2 is 32, divided by 4. So negative 9 plus or minus, I should have just factored. I just wanted to show you we could use something else. Sorry, I'm getting down towards the bottom now. Negative 9 plus or minus 7 over 4. So that's negative 9 plus 7 is 2 over 4 is 1/2. Negative 1/2. And negative 9 minus 7 is negative 16 over 4 is negative 4. So my zeros are, x equals 1/2, negative 1/2, and negative 4. My function factors into, okay, if I have a factor, or if I have a 0 of 1/2, that means that my factor is 2x minus 1, right? And negative 1/2 would be 2x plus 1. Yep. Okay. Let me find my paper. We're done. 180, 55 through 71 odd.